when we're talking about ionic compounds, ionic. So when we talk about ionic compounds, what type of compounds are these guys are going to be? What elements are they going to be made up of? Or what group of elements they're going to be made up of?
Non-metal and metal.
Non-metal and a metal, right? So I'm going to write a couple things up here. You got to remind me. Let's see. Tell me if I'm right or wrong in terms of this nomenclature. Is that right? And I'll give you the chemical compound that I'll be writing it for. Is that the name? Yes or no?
No.
No.
No. Right? Why is this wrong?
Because you're missing a Roman numeral.
No. In an ionic compound, you do not use the prefixes.
Ah, this is the reason why it's wrong, because it has dichloride, right? So we know that the name for this guy would be magnesium
Chloride.
Chloride.
chloride. And I don't have to put the Roman numeral because I know that magnesium is in group 2. Anything in group 1 and group 2, we don't use Roman numerals for, right? Is that correct?
Magnesium is not considered to be a transitional metal, right? It's a metal, but not transitional.
That is correct. Good job. Virtual high five.
High five back to you, Dr. Henry.
Okay, so let's see. This guy. Let's go. Let me write the chemical formula first. Is that correct?
No,
No.
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 Why is it wrong?
because in an ionic compound, since it's binary, you're not going to list the elements. You're going to list the metal and the other one, which in this case would be sulfate.
Ah, so I know that this guy is an oxyantacid. Daisy, are you here? Is there a Daisy here? No Daisy? So the correct answer would be
Copper 1 sulfate.
and. We also have to include that Roman numeral, right? To tell me the charge on the copper.
Dr. Henry, how come it's a 1 Roman numeral? I thought it was supposed to be a 2.
It's a 1 because remember, the Roman numeral represents the charge on the copper, right? We know
Right.
that sulfate has what charge associated with it?
-2.
-2. That's right. So we know that sulfate has a -2 charge. So we know that there are 2 coppers here. So each copper has to be what for it to balance out that -2 charge?
With the +2 charge? No,
1.
1. There you go.
You equal the +2.
That's right. Together they'll equal the plus. Okay. Okay, let's see. What about this guy? see.
Wait, real quick, Dr. Henry, I'm still kind of like confused on these. Like I'm starting to get the Roman numeral part, but like the 8 part, what determines that on these ones again?
Okay, anytime, because ionic compounds are basically, in almost all cases except for ammonium, it's always going to be a metal and non-metal, right? If you have more than one non-metal there, that's probably telling you that that is a polyatomic ion. Okay, so do you have that paper? Did you print out the polyatomic ion sheet or pick up the polyatomic ion sheet in your case?
Yeah.
Okay, so if you look on there and you look at SO4, do you see SO4 on there?
Yes.
Okay, so isn't that a polyatomic ion?
Yes.
So what charge does that have?
The sulfate,
Okay, it's called sulfate, and the charge on it is what?
SO4,
The charge
2 negative.
Charge. When we talk about charge, what does that mean?
That's that'd be the 2 negative, right?
That's right. Yeah. Okay. Okay. So 8 refers to, and it's called, anytime that you see the word ATE, that means that there's an oxygen there, an oxygen or a sulfate, right? Sulfate is a special case. Most cases, it's going to be oxygen. So you're going to have whatever the root is, that sulfur. So sulfur. So that means there's sulfur and oxygen.
Yeah.
Okay. Does that make sense?
Yeah. Okay, I'm
No.
starting to kind of.
So you need to use your tools. Your polyatomic ion table is a tool, or you can memorize, right? Most instructors have you memorize. I would prefer you looking at it because you're going to have Google anyway. So,
Yeah. Okay, yeah, I'm starting to see it.
okay.
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 So what he's saying is, because there's a 2- charge and then copper has that subscript of 2, you have to find out how many of copper you need to balance out that 2- charge, right?
You need to find out the charge on the copper to balance out, because you're given this in this circumstances, right?
Right.
You're given the chemical formula. And so since you're given the chemical formula, then it's already been assigned. So now you just need to figure out what it's being assigned as. Does that make sense?
So if that was like a Cu4 SO4, would it be copper 2 sulfate?
You're saying if it was Cu4 SO4?
Right.
No, in that case, it would be a half, right?
Oh, okay, yeah.
You got Cu4 here. Now, that is really hard to do now. And don't get me wrong, there are certain things that can make that happen, right? But those things are very unstable.
And that's a half because 4 goes into 2 basically half a time.
Because, yeah, so this guy has a -2 charge, right?
Right.
So since this has a -2 charge associated with it, then I have to have a 2 charge to balance it out. So
Right.
4 divided by 2 would be
Half.
0.5.
So if it was just CuSO4, then it would be copper 2 sulfate?
That's right.
Right, okay.
So then the Roman numeral, you said has something to do part like with the
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 charge
group-
on the copper.
the charge is a okay.
Charge. The charge. Yeah. CHARG.
Can you, I know it's redundant, but can you go over one time how there's like certain times last week where we were finding the charge off of the periodic table and by counting how far away it was from a noble gas? Do you remember when we were doing that?
Yeah. Yeah,
Can-
but that's because they're not transitional metals.
Okay, so
Okay.
a transitional metal like copper or whatever.
Yeah.
It's just going to be the charge that's associated with it there in the
Parentheses.
parentheses.
Yes, exactly. So remember, I told you guys this. Transitional metals are hot messes. The reason why is because you have to define what their charges are. Okay.
Right. So can we go over one more time? I know that we're trying to move past this, but I was having a hard time understanding how to identify a charge of a transitional metal in one of these equations.
Okay.
And then do the math that we're doing. That's kind of where I'm getting stuck at.
Okay, so we can do one more, right? So, but let me finish the one that I'm giving you right now, and then
Sorry.
we'll throw one more in. Okay.
Yeah. All right, thank you.
Okay. Okay, so we have, I'm saying this, ammonia. Is that correct?
No.
No.
Because you spell phosphate wrong. That's why.
And ammonia is NH3.
This was a trick question, y'all.
Would it be ammonia 3 hypophosphite?
Ah, so would it be
Ammonium.
ammonia 3? Is ammonia is it a transitional metal?
Hold on, let me see.
It'd be ammonium since it's NH4.
Okay.
NH. Oh, I'm sorry. Yeah. I'm looking at both of them and I do have both written down. NH4, that's what I meant. Ammonium.
So ammonium.
Yeah.
And then it's, you guys said what? It's
Three.
hypo.
3 hypophosphite.
So again, are you guys listening to what I'm saying that's coming out of my mouth?
Right, yeah. Hold on one second.
The only, let me type this down because maybe that's what it is. You don't.
Transitional metals with the Roman numerals. And since ammonia is
Only transitional metals.
right. And it's not a transitional metal. So no Roman numerals.
I could spell Roman numerals. There you go. And I probably misspelled Roman numerals. Okay.
So ammonium hypophosphite.
Yes. Okay.
I guess I keep getting kind of a little bit sometimes confused because there's on this polyatomic ion sheet, there's duplicates and then there's some that aren't, and I know that we have to work them out in our brain. But the duplicate ones throw me off. I think I'm gonna line those out and then put ones that aren't on there.
Okay. Okay. Okay, so let's talk now. So now that you guys have this, and at this point, you should be kind of clearing up these mistakes, right? So you know that Roman numerals will have, Roman numerals mean that it's a transitional metal, right? So you're telling that transitional metal what it is. So let's see, you were asking, let's do this guy. Okay. So how will we go about naming this guy?
First part is manganese.
Yeah. ASO or A505. Oh no, ASO.
Arsenate.
Per arsenate because
For
it has an
arsenate, I was
extra
about to say that.
oxygen.
Is that right?
And for the Roman numeral, since it's a transition metal, arsenate has a charge of 3 minus times 4 would make -12, and then just divide -12 by the 3 manganese, which would make each one would have to have a charge of +4. So
Okay.
just Roman numeral 4.
So we know that arsenate, per arsenate,
Who said that?
it's going to be 3 negative. So we have 4 of those, 4 times -3. That equals what?
-12.
-12.
-12. So then I have 3 manganese. So 3 times X
3 times 4.
is going to equal 12 because I have to equal 12 to balance that guy out. So then X has to be what?
4.
4.
Or
So that's going to be the charge on each of the manganese. So my answer should be manganese 4.
And it's per arsenate because it's one charge higher than the arsenate polyatomic ion.
It's not 1 charge higher, it's 1 oxygen higher.
Oh, one
Because
oxygen.
look at arsenate.
Yeah, it's ASO53.
Yep.
All right.
Okay.
This is all nice and everything, but on the test, it's going to be like 18 different elements with like 37 different numbers. All right. So we need to do one of them.
Hey, this is the real deal here. Like I'm giving you real questions that I put on real tests before.
Manganese.
Say that you're going to get this question. Right?
Yeah, right.
No, this is true.
I'm gonna
You
give you
know, the only thing that I'll say is there is one that I'm very partial to. Right? I'll give you one.
one that you're very partial to.
Mm-hmm.
Like a trick one, right? Because there's like a couple of these that can go different ways.
Mm-hmm.
Now look where his cursor is at. All right. He's subtly telling us it's ammonia phosphite. Ammonium phosphite.
Okay, so can I clear this so far? Because
Wait,
we're
let me
almost done
see.
with the ionic compounds here.
Yeah.
Let me screenshot it real quick because you said, oh, never-
Oh, too late.
Go ahead.
okay. Because you said one of these is going to be on the test. So I'm going to memorize these.
I didn't say that it was going to be on the test. I said I'm partial to giving you stuff that is like what I give you on the test.
I don't know. That's not what you said.
Okay, are you ready?
Oh yeah. You pulled a Randy Savage
No.
earlier when you said that.
Mercury. Done. All right. I'm going to try to do this one. Edgar, don't spit it out super fast. I want to try to work this one out in my head, all right?
That's fine.
Sorry.
Edgar probably got it worked out. It ain't even done getting written down yet.
Can't work it out without the second part.
Yeah, right, Edgar. You said take what you know and figure out what you don't know.
There you go. Now I know something.
All right. Don't say nothing, Edgar, please. Pretty please. All right. Let's see. OH. Where you at? Where you at? Hydroxide. Got a charge of -1. Okay, wait. If we were to charge H2, would it just be mercury hydroxide? Because, see, this is where I'm getting confused, Dr. Henry. Hydroxide has a charge of -1, right?
Correct?
So when I see OH with a subscript 2, does that mean it's like hyper
No.
hydroxide? Or like, how do I work that out? Is it OH2 -1?
That just means there's 2 of them.
Yeah, 2 hydroxides.
Take it back to the basics.
I know,
They-
but what I'm trying to say is, so then does that mean that the charge of it is -2 then?
Yeah.
As a whole, yes. Each one is still -1. but there's just
-1
2 of
plus
them.
-1, -2.
Okay. So
Yep.
-1 plus -1, so it's a -2. We
Right.
gotta balance it out. So it's just mercury hydroxide then,
There you go.
with no Roman numerals.
Why do you think no Roman numerals?
Because if it's a charge of -2 and you're supposed to make it 0 and mercury got 2,
Well,
if
you're gonna
remember
put
the rule-
1.
If you remember the rule for Roman numerals, transition metals, you got to put it. So if
Yeah.
you periodic
that's
table,
right. Oh,
If you don't see 1, then you're gonna put 1.
right.
But you're on the right track.
If it's just mercury hydroxide, you just put 1 because there's 1 mercury. So we
Right.
just that as 1.
And because it is a transitional metal, you have to make it indicative of it being so. So you're gonna put 1. But
Just
you got it.
I don't know. I don't know if I really got it.
You got it.
I got
Just-
there.
Just
but
this one.
now Nate, why did you say you're putting the 1 again?
I didn't put the 1. Y'all told me to put the 1, but Dr. Henry said when you don't have like a chart, like if it was just so -2.
No. Don't quote me because you guys we've talked about it. There's only certain circumstances, right? We've talked about this last week. We spent a lot of time. We were talking about silver. So silver is the one because it's a silver 1. Remember? Silver 1?
Yeah, I remember us talking about that.
Yeah. So don't put words in my mouth. So they're only special cases, exceptions, right? Silver is an exception. So when you see silver phosphate, right?
Isn't that because silver is a diatomic or whatever?
Nope. Mercury 1 is a diatomic.
Oh,
Isn't iron also an exception as well? Or no?
No, iron isn't an exception.
Okay.
Dr. Henry, from what I understood right now from Mercury is the only transition metal that is a diatomic element then?
Mercury 1
Mercury
is the
1.
only ion that is diatomic, yes.
Gotcha. Thank you.
that's why it needs the Roman numeral?
No, it needs the Roman numeral because it's a transitional metal. All transitional metals are going to need the Roman numeral,
Oh yeah.
except for silver, zinc. So when it's just written silver, we know that it's always going to be silver 1. So if you just see silver, that equals to silver 1.
I mean, but would you be wrong in putting 1 if you did put 1? Or
No, I won't mark you wrong for that.
But
Okay.
you'll mark us wrong if we don't put 1 and it needs it. That's what you're saying. So like,
That's right. So if it needs a Roman numeral, I'm marking you wrong.
So
But-
err on the safe side and put a 1.
if you read this, would you like if you read that, would you say mercury 1 hydroxide or would you just say mercury hydroxide?
No, you read it mercury 1 hydroxide. Because you could also have mercury 2 hydroxide. You could also have mercury 4 hydroxide.
Right.
Right? So if you don't tell me which one it is, I don't know which one it is. Does that make sense?
Right. All right. So if it's a transitional metal, you always put a Roman numeral. I knew that. We just said that a few minutes ago. But
That's right.
I was assuming because there was 1, we didn't need to say there was 1.
You need to.
Oh,
Okay. So again, the Roman numeral represents the charge on the metal.
Right. All right. Could we do another easy one like this?
Dr. Henry, what about aluminum? It can go 2 different ways. It could like plus
Now,
3.
aluminum is always going to be +3.
Plus, it's always +3. It's
Always
not there's
+3.
exception with that one regarding that one at all.
No, there's no question about it at all. Aluminum
Okay.
is always +3. So in that case, it's always just aluminum.
Okay.
Right? You don't have to put the Roman numeral there.
Okay.
Okay.
Man.
Okay. So one more for the road, and then we've got to move forward because otherwise we're not making progress.
Okay.
Okay. Let's see.
It must be hard for you to watch our little brain struggle.
You
I have a
have
big
no idea.
He's like, bruh, these are like counting 1 to 10, primary colors. Get it together.
He's also a doctor and we aren't. So just saying.
Yeah, that's definitely true.
Big difference.
All right. Where we at, chlorate?
And this is one of the ones that I love putting on exams.
CO2 1 minus. CO2 1 minus. So chloride 1 minus CO2.
Okay.
ClO2 1 minus.
I would say Hg2 parentheses ClO2.
Damn it, Edgar.
Hey, you didn't tell me to be quiet on this one.
I'm trying to learn around here. I hear you though.
Okay, so do you want to explain why you have to put? Actually, no, that is incorrect.
Ooh, no, I'm
A
just.
streak.
So that would be incorrect. Why is it incorrect?
-1 minus 1, that would be -2.
Put
Because
the
that
two
would,
inside. Put the
that
two
would be
inside.
mercury 2 chloride, right?
Ah, there we go. What is it, Christina? So Christina comes in for the save. Hg2.
Oh, I was looking at the wrong chlorite.
ClO2. And then 2.
There you go.
ClO2 and then 2. What?
I'm kind of starting to understand these a little bit. So, but what determines the parenthesis again? Needs parentheses.
If there's multiples, right? If you need more than one, right?
Oh, okay.
Since we know that Hg, so this really is Hg2. So mercury 1 is diatomic. So we know that it has to be written like this. Hg2 plus. Okay. So that means that we're going to need 2 of those to balance it out.
Okay.
Okay. Because we know that mercury 1 is diatomic. So this is one of those ones that I'm like, huh, I'm going to get you on this. Right?
So mercury 2 is diatomic, meaning it always has that 2 charge or that 2 subscript?
Yep, it always has the 2 charge and the 2 subscript. Mercury 1,
Right.
mercury 2.
So we will put Hg2, and then it's 2 chlorides because
We know that
-2.
chlorite has a -1 charge. So
So
you need 2 of them to
-2.
balance it out.
All right.
Okay?
Yeah.
Okay. So let's move forward.
So
What was that?
I'm starting to see it now. I'm starting to utilize I feel like I've just been missing my sheet. Like I haven't been looking at my sheet enough.
Yeah, that's right.
I've been staring at my sheet. It looks
That's
crazy.
what I mean. Like I feel like this whole time I had been missing like something. And now I can kind of see how to use the sheet. Yeah.
Okay. Okay, so if we have
5 more of those, please.
covalent bonds, we know that something like this let's do that. We would name this guy. Let's see. I'll ask if this name is correct.
Dicarbon triphosphate nitride.
Thank you for the answer.
I'm gonna say no.
No, because
No.
no
Correct?
transitional
No.
metal.
No.
No Roman numeral.
There's no metal, so we use the Greeks.
Non-metals don't require Roman numerals.
That's right. Okay, so then this guy would be called, you said dicarbon.
Triphosphate, right? Triphosphate.
Triphosphorus.
There we go, triphosphorus.
My bad. Triphosphorus nitride. The Greeks, man, they messing up my stocks. Now they messing up my homework.
Okay, simple.
Piece of cake,
So,
actually.
so simple.
Okay, what about this one?
Oh. Penta. Is 6 penta? Yeah, like a pentagram.
No,
Oh,
this
that's
would
five.
be hexa.
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 Sulfur.
Sulfur.
Pen.
Pentaoxide.
Oxide.
Pentoxide.
Pentoxide.
Toxide.
Okay.
Hecasulfur. All right.
Okay.
Hexasulfur pentoxide. Are those Greek written down on one of our sheets too, or we got to memorize those, huh?
You got to memorize those because you're going to see them. 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 And the time it takes you to go through and look at it, you know.
Can you just
And
go?
you're going to use them in organic chemistry. You're going to use them in chemistry. You're going to use them in, I can't remember what else, but you're going to use it in other things.
Life.
Biology.
You're gonna use it in life.
Everyone memorize 7, 8, and 9 because you know he's gonna put it on the test.
Oh,
Okay.
don't forget about 12
So
and 11, 10.
yeah, because 7, 8, 9. Okay.
Known, right? That's one of them.
Nona. Nona.
Nona.
So we have oxy and acids. I mean, oxy and ions. So these are our polyatomic ions, right? A lot of our polyatomic ions. So what is this guy called? Oh,
SO.
SO2 minus.
Hyposulfite.
SO2 to
that
no.
hypo sulfite.
2. So it has 1 like oxygen. Hyposulfite.
And what is this guy called?
Oh.
Persulfate.
Hypersulfate. Oh, persulfate, yeah. Persulfate.
Bro, Edgar is just too fast. Like, what the heck? He's bionic. How do we say that compound?
And so what is this guy called?
SO. Is that a 6?
Mega persulfate.
Mega. Let me see. SO6.
Does it have a charge?
No.
2 negatives.
So then what would you name it? What would be its name?
Sulfur.
Oh,
Sulfur hexoxide.
Sulfur. Sulfur oxide.
pentaoxide.
Okay.
Hexoxide.
So remember, don't forget the stuff that you just learned, right?
That was so long ago, bro. My brain already shelved that. Trying to make space for new information. Sulfur hexoxide. Heca oxide.
Okay.
Oxide.
Dr. Henry, you did trick me a bit right now.
Oh, I know. Okay. So now let's talk acids.
You sure you don't want to ask a slope question real quick, just while we're on the roll?
You said a slow question?
Yeah, y equals mx plus b out of nowhere, left field.
That's oranges. We want to talk about apples now, organic ones.
I'm still salty about that. I got blindsided. Oh, it's acid. This is hydrochloric acid. Do we want to practice test for nomenclature? Yes.
So we're
Chloe.
doing right now.
Okay. What about this guy?
Is it? Is it hydrochloroxic or hydrochlorine oxic?
I would say hypochlorous.
Hydrochlorous. Yeah.
Hypochlorous acid.
Yeah, hypochlorous acid.
Hypochlorous, huh?
We changed the "ite" to us.
Because of the oxygen?
Don't forget
No.
about the what is it called? Mnemonic. I ate organic apples despite them being poisonous.
I eat organic apples despite them being poisonous. This seems unsafe.
And that one would be chlorous acid.
Would it?
Oh no, it's gas. Never mind. You're tricking me
Okay.
again.
Yes, I did. So what would this guy be called? I love putting these on the exam too.
Dichlorous acid?
Hypochlorite.
Say hydrogen chloride.
Hydrogen.
Oh, there's no,
It's
what is that, a G?
Yeah, it's gaseous.
chlorine
Acid symbol.
dioxide.
Dioxygen.
I didn't look close enough. I'm gonna be cussing a lot during this test, all right? So for whoever's watching my proctor, I apologize ahead of time.
Okay. So, and that's because it has that G there. That lets me know that it's covalently bonded. Or if it had an L there, it would also be considered covalently bonded. Okay.
Chlorine dioxide.
Let's see.
Because it's not.
Let's see. Let's do one more. Let's do-
I'm excited to start this test so that I could go ahead and start my retest of it. You know what I mean?
There's some
Oh
optimism.
wow.
I already know where I'm using my what you call it?
Test correction.
Yeah, there's like another name for it though.
Dichromic acid.
Oh shoot, I didn't even see it. Dichromic.
H2CR.
Okay.
What
So
about
are you guys feeling good on the acids? Jamie,
Yeah.
are you there?
how will we be feeling good about this? What just happened with that one? Where'd the hydrogen go?
Wondering the same thing. Like, where's the hydrogen?
There's right there. Don't you see it in front?
It's the
Where,
acid.
where is it in the name?
The
Yeah.
acid. Acid.
It's in the sheet.
We got an acid sheet too?
No.
No,
Oh, but this
it
the
is the
compound of
acid.
chromate.
Yes, CR207 is chromate. And we know because of the mnemonic that Heather mentioned earlier, if it ends in 8, then you change the ending to ic acid. So dichromate becomes dichromic acid.
Wait, so we get that HCrO off of our polyatomic ion sheet?
You get the CR207, which is dichromate.
So again, where'd the dang hydrogen go?
It's with
That-
your aqueous.
You know
So
that
whenever you-
because yeah.
Okay, so let me see if I can clarify. I'm going to try to give you some clarity here. The reason why you said hydro, you say hydro only if there's no oxygen, right?
Oh,
That makes reference to there's no oxygens there, right?
all right.
So then that's why we call this guy hydrochloric. This guy is called hypo meaning lower. It's lower than oxygen than chlorite, right?
Oh, so the hydrogen ain't even in that one. I'm just done.
That's right. So
Yeah.
you don't put the hydrogen. The only time that you put the hydro there is if there's no oxygen there. Like for instance, this guy here would be called what?
Hydrosulfide or okay. Hydrosulfic.
Hydrosulfuric.
Oh, sulfuric. Oh, sulfuric. Oh yeah, sulfuric. I thought the
Then
farther
you want to put acid at the end, right? Don't forget that acid.
all right. Man.
And then what was what determines the hydro again? You said if it has.
No oxygen.
Okay, so let's go through this. We'll go through the acids one more time. Is it okay if I'm gonna add?
It's okay if you what?
I'm gonna
Get rid
add
of
a
it.
sheet.
Oh yeah.
I ate organic apples despite them being poisonous.
Well, we know why you ain't an English teacher. That's for sure. I'm just kidding.
Hey now,
Yeah,
is it?
there
There
you
we
go.
It's okay. Spell check exists.
I'm just playing. You know, Dr. Henry got a good mood today, so you know you could jab a little bit.
Yeah, I can take a couple punches, you know.
I wouldn't have done,
Let's see.
I wouldn't have done
And
it Thursday though.
my ride has
Hydro.
hydroholics. Okay, I know I misspelled that one.
That you get a pass on that. I don't think anyone
L-O-
know that.
Louics.
My ride has hydraulics. Is that what it is?
Yeah.
Hydraulics.
It's supposed to be like hydro, and then Louics.
LOUI.
So you're missing an O in between the LOU.
Okay, hold on. Are you sure?
I'm pretty
Yeah,
sure. it's spelled
that's what it says on your
hydraulics.
polyatomic ion sheet.
Okay, that's because none of us can spell hydraulics.
I think hydraulics is spelled Hydraulics. Hydraulics.
Just take off the U and
Close
the
enough.
Is it hydro? Is it supposed to be hydraulics or
Hydro is its own word underlined, and then X.
Okay, but we know that hydro is what we use for the thing. That's why we use, even though it's not.
we get the
spelled.
point. We get the point.
Okay,
That's
so
the most important thing. I'd.
See, if you misspell it, it's easier for us to remember. You know what I mean? It gives us like a memory point.
you say that.
Yeah, that's what I said. Cold hydraulics. Despite.
The I'd.
Okay, so if you see this, I'm going to circle it in green. Okay, what polyatomic ion is that?
Hold on, Edgar. Hold on.
That's sulfite.
That's right.
That is sulfite. Okay, so we know that that guy is sulfite.
Mhm.
So anytime that we see that it's sulfite, we change it to OUS. So now it is
Sulfus.
so, and then we always put the whole thing. Sulfur.
Sulfurious.
Wait, so
Yeah.
the whole point of that sentence is if it says ate, ick, or ite, we change it to us?
OUS.
No.
Yep. So you take the root, and then you put OUS behind it. And then
The
you put
eight-
acid.
The red goes with red, the blue goes with blue, the green goes with green.
Oh, so if it's ate, you change it to ick. If it's
Right.
ite, you change it to us.
Okay,
Right.
so for instance,
If it's ide, you change it to Olablix.
Ick.
All right.
okay, so if I have this guy,
Oh, you change it to hydro ick.
Hydroics. Yeah.
You're gonna see hydraulics on my test. Sulfur hydraulics. Oh no. All right. H3ASO5. That's that arsenate, right? Let me double check.
is it arsenate?
No, it's
Mhm.
hypoarsenate.
Is it
Hypo-
hypoarsenate?
Per arsenic acid? No.
Remember he said earlier?
No, it ain't acid because they don't have an AQ. So it'd be like hyperarsen.
No, it isn't.
No.
I forgot my AQ. Let me put the IQ there. Thank you.
Oh,
Yep, now it has the AQ.
got it, got
And
it.
then this guy would be,
Hydroarsenic. Hyperarsenic. Hyperarsenic?
nope,
I just throw
Per
it out there.
arsenic.
No hydro,
Yes.
because you have the
per
aqueous there.
arsenic acid.
Hypo.
Yeah.
Hyper.
So when you're gonna,
Remember, O means no hydro.
yeah, you're
oh,
omitting,
no
you're
hydro. That's
omitting
right.
that hydro.
So per arsenic. No H mean okay. All right.
Okay, so let's say we have this guy.
Hydraulic apple
Hydro.
H3P. Let me look. Okay, so that is a hydro.
Phosphorus, phosphoric acid.
Hydrofluoric. Is that what the hydraulics is about? If you got hydro, you change it to ic. Yeah, or yeah,
That's right.
hydrophosphoric.
Hydrophosphoric.
So because that's what that my ride has hydraulics. Why'd you circle ride? Is that the IDE?
Because this guy, if we had just P3 minus, what is that called?
Phosphide.
Phosphide, right?
So my ride, so phosphide. So my phosphide. Hydrophosphoric acid. Hydroic. Hydrophosphoric. All right. It's coming. Something's happening in my brain. I don't know what. I feel movement.
Okay,
I ate organic apples despite them being poisonous. My ride has hydraulics. Shift command 4. Go ahead and copy this.
okay, so what is this acid called?
All right. HNO. So we don't say hydro.
Is it nitric acid?
That is correct.
Yeah.
Okay,
Nice.
is that good?
That's great.
Yeah.
Jamie,
Nitrate.
Oh,
are you there?
Nitrate. Is who here?
Jamie,
Oh. Nitrate. So nitric. So
Oh, okay. I'm starting to see how this little I eat organic apple thing's coming into.
because we know that this guy is nitrate, right?
So it's nitrate, and then it'll be the next one, right? The next.
And because there's a O, we just dropped the H out of the name.
Yeah, so this guy is nitrate.
Okay, hang on. Give me just a second, real quick, to write these bad boys down.
Screenshot it, Tugger.
Yeah, I'll just take a picture of my phone so I don't hold everybody up with my slow writing.
No, you're good, man. Take as much time as you need.
Hey,
No,
now.
let's move it along. Let's get,
That's all right, because all the stuff at the end, if we don't get to it, it'll still be on the test.
no, thanks.
I know, but if we don't learn it, it don't matter if it's on the test or not, because it's all gonna be wrong anyways.
If you click annotate, the Zoom gives you an option for screenshots, so you don't.
Yeah,
have to
yeah,
write
yeah.
anything.
No, yeah.
If you got a Mac, you just press Shift Command 4 and take a screenshot of it.
Okay,
It's a lot easier to look at it with my phone than.
did you get it?
Yep, I got it.
Ooh.
And then we have our hydrates.
Hydrates, that's when it's like a H2O at the end, plus H2O, or times H2O or whatever. So that would be silver carbonate with a times symbol and then a like 5H2O or whatever.
Okay, so what would be the chemical formula?
Silver Ag. Let me see what carbonate is real quick. CO3 minus 2 Silver's diatomic, so it'd be Ag1. Do we have to put a 1 there? We have to put a 1 there, right? Ag2.
Yeah, you need to. It's transitional.
So I need 2.
CO3.
Why do we need a 2? CO3 has a 2 minus charge. Silver's already whatever.
Not diatomic.
It's not diatomic?
No,
Earlier it was.
no, that's mercury.
Oh, I'm dumb. My bad. H2O.
Remember that since silver is the exception, if there's no numeral, it's a 1 plus charge.
Silver and zinc.
I did too much freelance chemistry in the past, so my memory's not that good. Ag2CO3 times 5H2O. All right.
So you learned about acids really early, is that what you're saying?
Oh, yeah. This ain't the first time I had a sheet for acids. Just-
Okay.
Well, how
So
do
you
you,
guys are feeling comfortable so far?
I have a question.
Yes.
Well, how do you know when you're supposed to put the period in the middle of
Anytime that you see hydrate, right? If you have a hydrate there, then you put the period. There's one thing that I need to add on to it, anhydrous.
Okay.
Anhydrous basically means without water,
yeah, that means dry, right? I already know
Yeah.
that one.
okay? So if something is anhydrous, it's letting you know that at one point they had water in it, but they removed it, okay? So we'll put anhydrous. So we'll say silver chloride anhydrous, right? So that means it started off with water in it, but they removed it.
Boy.
So because certain reactions, if you have water present, it can cause explosions. And so you want to let people know, well, the silver chloride had water in it at some point. So if Johnny was responsible for removing all the water of the silver chloride, you know you want to go to Johnny if everything blows up. So this would just be AgCl, and that's it.
All right.
Okay. So anhydrous means without water.
Wait, so if you were to write it, you would just write it with nothing there, just AgCl.
And you're just letting them know, you're letting the person know that at some point it had water in it, but we removed that water.
Like by combustion or whatever, right? Like you burned it off.
Yeah, you burned it off in most cases.
Dr.
Now back-
Henry, how come there's not a 2 after chloride, since it's AgCl?
Because it's silver chloride.
So they're
Right.
already balanced then, right?
That's right.
Because
Not because silver has a +1 charge, chloride
Right.
has a -1 charge.
Right, that makes sense now.
Okay, organic chemistry, let's get it, right?
Do this.
You guys are ready?
Oh yeah,
Mhm.
this one I'm
Yeah,
actually,
I actually like these.
yeah, we did this in the lab or whatever. This is
I missed it. Let's do it.
I got so lost the other day.
Yeah.
I got a little less lost on this than I have on everything else.
Oh, for sure. I was the same way. I'm still lost on nomenclature.
We all are, Tucker. We all are.
We're all lost in different ways. All right, I'll just bug Dr. Henry tonight on his office hours.
Everyone's lost except for Edgar.
No comment.
This is Edgar's third time taking the class for fun.
For fun.
I bet you like $10 Edgar gonna be the next TA. Cole, you hear that? Edgar coming for you. Coming for that job.
There's gonna be a TA fight, a TA bash.
Yeah, but Edgar has to challenge Cole for the role. So they have to have
By combat.
a chemistry off.
Oh,
Yeah, I'd pay to watch it.
You guys got to do chemistry against each other, like rap battle of history.
Okay. First off, organic. What does organic mean?
Oh,
Natural.
they have carbon?
chain of hydrocarbons.
Ooh,
Okay.
actually, that's
So they have carbon. So are there exceptions?
Yes.
Yes.
Okay. Let's see. Is this organic?
No.
No.
Is this organic?
No.
Yes.
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 Okay. So this is organic, but this guy is not organic.
Does it have
Okay.
oxygen?
And no, it's inorganic because, well, it's considered to be quote inorganic. It's called an inorganic carbon or inorganic carbon. So carbon dioxide, so CO2, carbon monoxide. What's the other one I gave you? Carbonic acid and carbonate. These are all the ones, they're exceptions. So
Because it's
the
not reusable.
organic, they're beneath the organic chemists, so they don't like to accept them. They're elite club. What was that?
Is it because they're not reusable? Are those three? You said those three?
Yeah, these three. It's not because they're not reusable, because we can use CO2 and we can reuse that to sit there and make, because isn't that what we use to sit there and make sugar molecules? Or plants use to make sugar molecules. So no, it's just a definition that somebody had decided long ago, and they wanted to exclude those just to make it a little bit harder.
But isn't carbon dioxide like the byproduct of like photosynthesis or whatever?
No, carbon dioxide is what is needed for some photosynthesis, right?
Oh, what do the plants put off or whatever into the atmosphere? Oxygen.
Oxygen.
Okay.
So remember, it's opposite of our combustion reaction with sugar, right? So with combustion, we'll talk about that. Actually, we did talk about it. With combustion reactions, we use hydrocarbons and oxygen to make carbon dioxide and water. Well, plants use carbon dioxide and water to make sugar
Where do they get the
and
carbon
oxygen.
dioxide?
Where do you think they get the carbon dioxide from? What do you breathe out?
Oxygen or carbon dioxide?
You
So-
breathe out carbon dioxide.
But how is it not natural then? That's
What was that?
What I'm getting at is how is it not natural then if it's naturally occurring?
I'm not saying that it's not natural. I didn't say that. Organic does not mean natural. That's what you guys have been taught, right? That's wrong. Organic just basically means it has carbon in it.
That way we spend more money on bananas at the store.
That's right. You spend $8 on bananas instead of, $1.25 on them.
I got you. But it's the same stuff.
Yeah.
Nice.
Okay. Let's see. Okay, so let's see how much you guys. Okay, so we've already talked about that. The other thing that I want to talk about, hydrocarbons. Hydrocarbons are just anything that has only hydrogen and carbon in it. So is this guy up here, what I pointed to right here, is this a hydrocarbon?
Yes.
Yes.
What about this guy?
No.
No.
Okay. Okay, so hydrocarbon, not a hydrocarbon.
Because it has oxygen?
because it has oxygen.
Okay.
Okay. Good so far?
Yeah.
Okay. So let's go ahead.
Okay, wait, I'm still at the exception, sorry. So if it has oxygen, then it's good. If it doesn't, then it's not.
Okay, the term hydrocarbon means it only has carbon and hydrogen in it.
Okay.
Okay. So this is A, this is B.
Oh,
Which one
okay.
is a hydrocarbon? A or B?
Hydro B.
Okay, now what was the definition of hydrocarbon again?
Sorry, carbon and hydrogen only. So
Carbon
it's
and hydrogen only. So which one is a hydrocarbon? A or B?
C2H6. A.
Okay,
I got thrown off with the A's and the B's there.
No, it was just funny because you were doing everything but saying A or B.
Oh,
You're just you were just naming it, reading it.
you guys just like to make my life difficult, that's all, right?
It's fun. It's just funny.
Okay, so what defines if they're organic or inorganic again? Okay, what is the definition of organic?
Contains carbon.
It basically has carbon, but these are exceptions right here. Okay, inorganic is anything else that doesn't have carbon in it. These guys are included as inorganics because they have nowhere else to go. They're like orphans. The organic chemists dump them, so we accept them. So these guys would be called inorganic carbons. Okay. Let me add a page.
Dr. Henry doesn't like organic chemists.
I don't hate on organic chemists. They make things fun, you know.
I agree.
A lot of our drugs basically comes from organic chemists. Okay, so we have what we call alkanes. Okay, so here I'm going to underline that A and E. Alkane basically means that everything there is going to be single bond, right? So we talked about this yesterday. Or yesterday, 2 days ago. So we could write out our structures as expanded structures like this. This is called an expanded structure for our chemical formula. We can write it as a compressed structure, which I didn't talk to you guys about. Or we could write it as, sorry, my lunch just came here. Give me 1 second. Or we can write it out as a skeletal structure.
skeletal.
Okay, so here each point represents the carbon. Now, since you put enough carbons to satisfy the octet rule, we know that carbon could have 4 bonds, right? So that's 1, 2, 3, 4. No, I'm still on. Okay, so carbon could have 4 bonds, up to 4 bonds, right? And it keeps obeying the octet rule. So that's the maximum it has. So when it's saturated, the term saturated basically means that you only have single bonds. Have you guys heard of saturated fats?
Yeah, they're good
Yes.
for you.
They're not good for you, right? Isn't it the opposite?
Right, that's right. Sarcasm.
Okay, yeah, no, I'm not good at that.
Okay. So alkanes are all saturated. So these hydrocarbons are saturated. So meaning that they only have single bonds. Now, the way that we do nomenclature is based upon the number of carbons in organic chemistry. So you'll see things how we name things inorganically in terms of covalent bonds, organic chemists will rename it and name it in their fashion, right? And so there's a lot of things that we'll cross over with, okay, with their naming. So we name it based upon the number of carbons we have. How many carbons do we have here?
3.
We have 3 carbons. So this guy would be called propane. Propane, okay? So what we do, we put the prefix prop, and then we add ane, letting us know that there's only single bonds there. Does that make sense?
Yeah.
Okay, so because organic chemists are lazy, just like chemists, they prefer using the skeletal structure. It is a lot easier to write, okay? So if we have long hydrocarbons, let's say we have this guy.
1, 2, 3, 4, 5, 6, 7, 9, 10. Decane.
Okay, so what would we name this guy?
10.
Decane.
Okay, simple?
Okay, wait. Right, like underneath the first one to the left, what would you call that one?
Propane.
This guy here?
Yeah.
It's the same thing as it up here. It has 3
Oh.
carbons, 1, 2, 3, propane.
So each point is the carbon.
Each point is a carbon, yes.
So what if we had like different elements? Could we are we still writing it like this, up, down, up, down?
Nah, he's gonna.
Zigzag?
Okay, don't get yourself confused. We're only talking about hydrocarbons right now.
Oh, okay. So this
Okay,
only.
don't worry. I'll confuse you later, I promise.
Okay.
Okay,
And for some of us, he's going to be confusing us again.
so again, this is propane. Okay, simple so far?
So far, so good.
Yes.
Okay, so let's do one more for the road. 1, 2, 3, 4, 5. Okay,
These prefixes aren't on a sheet either, huh?
No.
nope.
Heptane.
Bro, I can't remember.
Heptane.
This
Okay,
stuff.
so that's 1, 2, 3, 4, 5, 6, 7. So you guys said heptane.
I'm gonna be over here naming it triane. 'Cause I can't remember now.
Try.
Okay,
Heptane. Okay.
Got it. Finally something that
So this is only pertaining to hydrocarbons.
that is correct.
Okay.
hang on, my cat's about to eat my here.
Oh no! Can you put it back real quick? I'm trying to
Sure.
steal your information. All right, I'm good. Thank you. Just so I have these prefixes and a little reminder sheet. Basically, when I study, it's like a little PowerPoint of all the screenshots I've taken from class.
Okay, so the next one is alkane. Alkane basically means that there's a double bond in our structure. Now, it doesn't mean that everything is double bonded. It just means that there's at least one double bond. So the way that we would name this structure, you'd have to tell me where the double bond is located at, right? So we'd have to count our carbons. And you want to count it so that the double bond has the lowest number associated with it. So if I count it in this direction, 1, 2, 3, 4, 5, the double bond starts on a 2 carbon. Okay. If I count it from the other direction, 1, 2, 3, 4, 5, the double bond starts on the 3 carbon. So which way do I want to number it? The orange or the green?
You're lazy, you want to go red, right? I mean,
Orange.
orange.
That's the lazy.
Orange.
Yes, orange.
Okay, so we want to go with the orange. Okay, so you use where it's located to tell me where the double bond is at, put a dash, and then you tell me how many carbons are in that hydrocarbon.
Pent.
Pentene.
Yeah.
And then we use the suffix ene to let me know that there's a double bond there.
Okay, 2
Okay.
is where it's located. The dash is indicative of what?
The dash is just to let us know it's 2 dash. It's telling us that, hey, on the 2 carbon, there's a thing. We just use the dash to kind of
Like a
separate
space
it.
holder? Okay.
It's going to be important later on, don't worry.
And the E and E is the double bond.
Yep.
And then pentane is the double bond, you said?
Ene, E-N-E.
Yeah, E.
Yeah, ane would be single bond and ene is double bond.
Sorry, pentene.
Yeah. So pentane would be just all single bonds. And pentene is at least 1 double bond.
At least 1 double bond.
One, two, three. 1, 2, 3, 4, 5, 6, 7, 8. Known. 2, 4. Nonene. 2, 4. 2, 3.
Okay. So you can have multiple double bonds. You have to let me know that you have multiple double bonds. The way that you would do that is
Write all the locations in front.
you write the locations in front. Okay, so we're starting at which location?
2.
2,
2,
Or
2, 4.
honey.
2, 4. And then you tell me how many carbons you have. You said nonene. And then we say nonene di, meaning for 2. So now you have to use the Greek prefixes, ene.
Die.
Oh, I forgot the die.
Known.
None.
It's not dinonene, it's known diene.
Yeah, it's known di because it goes directly with in front of that.
Known die.
Because if you go di nonene, that means you have 2 of the di of those guys, which you don't have. That means something different.
So it goes in front of the ene because there's 2 double bonds.
That's right.
Non-diene.
And so if we had 3, it'd be triene.
No, non-triene. Yeah, I think so, right?
That means it should be actually this way.
Nona.
Nona, yeah. Nona diene.
I thought it was Nona from earlier too.
Would we be docked if you just put non?
No, you won't. You won't. Yeah.
So say there was another one, like a third bond starting at the 6, it'd be 2, 4, 6 dash nona triene. TRIENE.
Yep, that's right.
Right to me. Yeah. Sound good.
Okay. So this is one way of writing it. Another way of writing it, I know it's nasty, would be okay.
That kind of makes more sense though, because you're putting the numbers with the double bond.
Yeah, but it looks so nasty. It just
Yeah, I'll go the other way.
Option 1 is better.
It does look cleaner the other way, but this makes more sense, like for what you're trying to say.
Yep. Okay,
Uh,
questions? You guys got it so far?
Yeah, this is organic. This is what our extra credit's all about, right?
Yeah.
I think the whole
And
test is on organic.
Okay, so let's see those skills. Actually, let's do this.
Nona dying. All right. Blip 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Deck. Try in 1, 4, 9. Deck. Try in 149 deck trying, I think.
Okay, so first thing we want to do is count our carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And you said, where's the first double bond?
On 1.
1,
The second one?
4,
4, and
The
9.
last one.
9.
9. And then deck.
Probably
Trying.
Deca. Oh, yeah. Deca trying.
Or deck.
Try. Yeah, I forget. I always forget those A's. My bad.
Deca trying.
Okay.
Yeah.
Simple so far?
Simple so far.
Okay.
For simpleton.
Mm-hmm.
Oh my.
Okay. So the next one we have is 10. Is alkyne. So alkyne is a triple bond. So if you guys notice the trend, A and E was a single bond, E and E is a double bond, and triple bond, which is the most you could have, is Y and E.
Can you write that in the corner or something? So when we're doing this, I don't know if that's too much. My bad.
And you're asking for too much.
I'm being extra today. I always get extra right before tests. You know what I mean? Got to get it locked in. The test on the 23rd, right? What's today?
Yep.
For
It
you,
opens up on the-
22nd.
Probably. What's today's date?
The 23rd.
Oh, all right. I guess this is a study session.
Nate, you were supposed to screenshot this yesterday when you had the amine, this on it.
I'm pretty sure I probably did. But I double screen.
I want him to work some more.
Girl, you should see my desktop. I can't even see the background anymore. It's getting ridiculous.
Are you guys feeling worked? Is that what you're telling me?
No, I just take so many screenshots you can't see the background on my desktop because they save automatically to my desktop.
Oh god.
Nah, he's telling you to do some more work just because.
Oh, now Brittany wants to show up and start talking trash. You weren't here in the trenches, Brittany, when we was learning this earlier.
Yes, I was. I just don't have my camera on because I was at work.
Oh, okay. Let's show. All right. Alkyne. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay. So first thing we're going to do is do what?
Count the carbons. The longest.
Okay.
Carbon.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay,
Non-9.
No 9.
okay. What am I going to do about the triple bond?
Put a 2 there.
Okay. Piece of cake?
Somebody gonna ask why it don't bend.
Not a piece of cake, but makes sense.
I'm getting there since I was lost on Tuesday. Second chances do matter then.
Got to double down. So it's for anybody wondering, it's too thick to bend. That's why he draws a straight line. He went over that the other day though.
I was wondering that. Thank you.
But you counted at each side. So you count at the beginning of that 3 lines and at the end of the 3 lines. Like he did.
That's what I was, yeah, I was figuring. I was like maybe thinking because of the break, because at each point.
In your head, you could just picture it as if it was bending, but because it's a triple bond, it's too thick to bend. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, there we go.
That's how it would look like that then too.
It's the same thing. You count each end of the triple bond and then each bend.
Which way are we going to get it on our exam, Dr. Henry? Not that it really matters, I guess. But...
It's going to be straight. They're going to be
Oh.
drawn out the way they're supposed to. So you're going to get it like this.
1,
Okay.
2, 3, 4.
But be prepared for either way because it just depends on the tool that you have to draw,
Yeah.
right? So, but normally you draw it as straight because it can't bend.
1, 5.
Okay, first thing we want to do is do what?
1, 5 Undecky.
Deck dying. Right? 1, 5 Undeck dying.
Whatever it is, you know what I mean. Something like that.
Sounds like we're speaking a different language.
Sounds like we're speaking
my
that
God.
correct language with the big foreheads.
Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you guys had 1,
1, 5
5.
Undeck dying. Undeck
Is
dying.
it deck? Or did you say undek? Undek. There we go.
Undeck
Undek.
That guy.
die. Fine.
Okay.
That's my guess.
That is so
Code
nasty.
language.
You drew it, Dr. Henry.
I know, but it's still so nasty.
But so you have to separate the.
Deck and die.
Do you separate it or don't separate it? Doesn't matter.
You really wouldn't separate it, but it just looks so nasty.
It is. It does. I agree.
Undeck dying.
Deck and die.
Okay. Undeck trine.
Okay.
Just a heads up on the test. There's going to be some crazy spelling. It's going to be.
How you know?
And Dr. Henry's famous words. Now you're just making up shit.
I thought Tucker had an advanced version of the test. I was like, slide that over here, Tucker.
Okay. So now you've been introduced to hydrocarbon. You could have cases where you have all three. So you already know in the case of the single bond, the double bond takes precedence, right? In the case of the triple bond, if you have a double bond and a triple bond, the double bond takes precedence. So double bond has priority. So we put
Over
them in
all
order.
three?
Over all three. The double bond has priority because they're more frequent. You have them more often. So they have, well, I should say, they're not more frequent. They have more importance. Okay. I should say a double bond is more frequent than a triple bond.
And the
So-
amines are for all.
Yeah, we're getting there. We're getting there. We haven't got to the mean part yet. I know we're over, right?
I gotta leave soon. My kid finally went back to class and I'm still here sitting on the computer.
So when you said that this exam is going to be like one of the shorter exams,
Yep.
how short are we talking?
It's going to be the same number of questions, but it's just going to feel like it's shorter.
I
Not
see it.
sure.
Because as I say, we're covering a lot of material, so I was getting a little concerned. I was like, wonder how many questions we're having.
Okay, so
He's going to add questions. Remember what he did last time? Are they multiple choice now that we're asking about the test?
you're going to have both.
I always get worried when I turn in the test because it says to turn the paperwork in at the end, but then there's a submit button during the test. So
It's trying to test your cognitive level.
right, but I haven't been submitting during the test. We're not supposed to be submitting during the test, right?
Yeah, that's
That's
because it has issues with it sometimes, and
Okay.
it kicks you out. So
Because I just been skipping those questions, and then it shows like I got a lower grade than what I'll ultimately get, right?
yeah,
'Cause-
and that's because I have to grade them by hand. So all those questions.
yeah, that's what I assumed. I was like, I hope I'm doing this right.
Okay, so as I said, we go into the priority. We know that alkenes have priority over alkynes,
Oh, yeah.
and that has priority over alkanes.
Cane.
2, 3, 1. That's the priority. That's great.
Okay, so what will we name this guy? First thing that we want to do is what?
Count them.
Count the carbons.
Okay, count the carbons.
1, 2, 3, 4, 5.
So the base is the decene.
Mhm. Okay, so the way that we would go about doing this, we'd call this, we'd give its base first, and then we'll put the prefix, all the stuff in front in a second. Okay, so there's two ways of doing this. One way is you have a prefix way of writing a triple bond, and that's by using the YN. Okay, you tell me where it's located. It's located on 10. Then you tell me where the double bonds are located. Where the double bonds located?
1 and 3.
So, dec, diene.
All right, you're writing it the messy way first?
Yeah, I'm writing it. Well, this is the good way. I'll show you the messy way in a minute. I like this way better than the other way. Okay.
Henry, thank you.
What's
Okay.
the YN?
YN just means double
For
bond.
the triple.
So it's I'm sorry, triple bonds. Yeah, thank you. Triple bond. So it's there's prefix ways of writing it, meaning that it goes before the last name, or you could put it in the middle as well, which is what I'm going to show you how to do that now. So you can call this guy. So,
The YN, the 10 is the triple, right?
that's right.
Oh, I see. The 10 dash YN equals, the whole thing equals triple bond.
Mhm.
And then the 1 through 3, 1,3 is our doubles.
And then the dodecahedron. Okay, I see it now. I see it.
Bond.
So the triple will always go first.
Yeah, because that's the hierarchy.
All the
Yeah.
terms are single.
Okay,
There.
so remember the last name is given to the person who's the most important, like in our culture, right? The man is most important, so the woman takes our last name, right?
So women nowadays, they keep their last names too.
Facts.
True.
Okay. Okay, so you guys get that, right?
Yes.
Yeah? No, maybe?
Yes.
Dodecans, 12 points, 12 carbons. Carbon. Write that other one, dodeca. And 1, 3, B. Yeah, that one does look messier. Okay, same thing. Okay, and this one, what is this one called?
So this is actually just a mixture of them all. So this is just looking at priority. Okay, so let's talk shop. So we left off, we were talking about all of the hydrocarbons, right? So we talked about alkenes, alkanes, and alkynes, right? And then when you have mixtures of them all, you can also have what we call branching structures. So when you have branching hydrocarbons, you want to sit there and find the longest chain. So that's your first thing that you want to do. 1, 2, 3, 4. And that would be 5 here. Or I could go 1, 2, 3, 4, 5, 6, 7. So which one is the longest chain?
5, blacks.
5 is the longest chain?
Right? 1, 2, 3,
It's the
4,
longest.
5.
The purple?
The purple is longer, right? 1, 2, 3, 4, 5, 6,
Oh.
7.
Yes, I'm looking at like the longest like straight line. Sorry. I was looking at like 2, what is it, 3 to 5?
Okay, so you want to make sure that you have the longest chain. So then that tells me that that's going to be what carbon?
7.
What
Or
prefix?
The pentane.
Okay,
I'm sorry, heptane.
heptane. Okay, so now if we take a look, we have groups hanging off of that, oops, sorry.
2,
Dr. Henry, it's heptane because of the single bonds, right?
4.
Yes, it's A and E because all single bond.
Yeah, the 7 single bonds I get now.
Okay, and
5.
and we
Now you're
have
gonna name your methyls, right?
we have
The 2, 3, 4,
that is
4.
correct. Yeah. Okay, so we have things hanging off the main chain. So the one that's in purple, that represents our main chain. We have a single carbon hanging off of the main chain at 2, at 3, at 4, at 5. So when you have something hanging off of it, that's a single bond. You count how many carbons it has hanging off. That's 1 carbon hanging off. So it would be meth. So then what we would write is it would be methyl. There are 4 of them, 1, 2, 3, 4. So we would use the Greek prefixes, tetra.
Mm.
And then we have to say where it's located at. We have it off the 2nd carbon, the 3rd carbon, and then we have 4, 4. So we have 2 off the 4th carbon. Okay.
2, 3, 4, 4. Tetra. Methyl. How do we know it's methyl?
Because it's only a single carbon that's hanging off.
I mean, how do we know to put the YL?
Because it's only a single carbon hanging off the main chain. It's hanging off the main chain, right? It's a side chain or a branch.
Oh, I get it. YN was triple. What's double?
A double bond is EN.
Thank you.
And
We're on
so,
the same page now.
what was that?
We're on the same page now.
Okay.
YL single. You said YE, right? EY. Which
No,
one's double?
double is EN.
EN. EN double. YN triple. Okay. Heptane.
Okay. So this guy here.
Gonna have oct.
Octane.
Okay. Octane what?
So would this be 3,5-dimethyl for ethyl octane?
So you said 3,5-dimethyl
Mm-hmm.
or
Ethyl
ethylene.
octane.
That is correct.
I'm doing a little happy dance.
Okay, wait. Why is it A and E again?
It's all single bonds. A and E is all single bonds.
On your main chain, it's all single bonds.
Okay.
Don't forget the alkane, like just the screenshot from before.
A and E equals all.
And how
single
come it's 4-ethyl?
Because if you look on the fourth carbon, it has
The low
two
station.
carbons hanging off of it.
Okay, so
Oh, okay, that makes sense now.
Oops.
3, 5 dimethyl 4 ethyl octane.
I don't know if this will help someone else in the class, but for me, like this feels kind of like the word problems. If you have to, you should ask yourself certain kind of questions so you don't forget to write certain specifics about it. At least that's helped me. Like, where is it? How much is it? Et cetera, et cetera.
Okay. Yeah, I like to break it down, like, so like the 3 and the 5, I'll put like a circle and I'll put an arrow and then I'll put like what that means. And then the dimethyl, I'll break that down, put an arrow and then write down what that means alongside it. So I was trying to figure it out.
Okay.
Just give me 1 second just to write this a little bit. Right.
Jocelyn, didn't you email me about your group?
I did.
Okay. So I checked out your group. They're still here. They're still in class. They're still turning stuff in. So they're there. You tried emailing them via Canvas?
Yes.
And
All
they've not responded?
No, 3 have, but like honestly, I look for them even in class. I usually don't see them. I think I've seen like 1 in class before. Like right now, I don't think any of my
So
folks are.
sometimes they might be coming to the evening one. So
Right.
Yeah.
But no, but it's just I'm getting concerned because I like to do things like that early because there's so many different people and there might be, you know, technical difficulties and all this other stuff. And I just feel like I'm not really getting much feedback. So I'm getting kind of worried because if there's only one person really giving me major feedback and there's 5 of us, that's a problem.
Yeah, I agree.
I hate group assignments, just saying, and I wish there was a way that if we didn't all each do different material, that you can put the ones that are actually participating and doing the work together and drop the ones that aren't, and then put all of those guys in a group together.
But is that realistic?
I'm saying.
Does that happen in real life?
No, like I literally
No, but
tried to find a way in my brain where that could work, and I was like, well, we can't. We're all doing different genres.
But no,
and stuff. Yeah.
Dr. Henry, in real life, people get reprimanded for not participating. Mm-hmm.
Oh, I reprimand them. And you reprimand them as well, right? When they get their grade. So, but do they usually get reprimanded after the assignment for them to do whatever they need to do is turned in?
Yeah.
Mm-hmm.
Also,
Dr. Henry.
will you
Yep.
take into consideration, like say somebody, I mean, my group's fine right now, it's still holding down with 6 people, but like say a group had 6 people and then it ended up with like 2 people, the workload that group of 2 had to do compared to a group of 6 is not equivalent.
Okay.
Is that taken into consideration? Like if all of a
No.
sudden, say the people in my group dropped and then there's
I have to tell you, is Cole here? Cole, how many people were in your group when you gave your presentation?
When I gave my presentation, it was 2, me and one other person.
Okay. And how did you guys do on it?
I did fairly well. Yeah. We started with like 6 or 7 though.
What was your genre?
I was doing a different project.
Your projects are so much more fun than their projects were. So.
I would have to probably disagree.
Do you want me to send you my project? You can take a look at it.
And you can send them the paper as well too.
Yeah.
And
Okay,
I think I have a recording of your presentation.
Mm-hmm.
For this answer, would this be 4,4-dimethyl 5-propyl? How would you say that? Propyl?
Propyl?
I think 4,4-dimethyl 5-propyl 2-octene.
4,4-dimethyl.
Mm-hmm. 5-propyl.
5-propyl.
Yeah. 2-octene. Or is that written differently because of so many?
1, 2, 3, 4. Say 1, 2, 3, 4, 5, 6, 7, 8. Nope, that's correct.
Ooh. So this is all considered branching hydrocarbons.
That is correct.
All right.
This is what you want us to do on that 5-point thing?
Yeah.
Yep. And then also provide the name. You write the structure, you provide the name. You write the name, you provide the structure.
Oh, I see. So reverse.
So you want us to give us 2 examples.
That's
and
right,
answer our own examples.
That is correct.
Oh, I thought you just wanted to give, like, you just wanted to.
Okay, simple so far?
Will this part have we gone over? Will it help me finish the last part of the lab that's due tomorrow?
Yeah, it should.
Got you then.
I think most of it, except you may not have all of the functional groups here. So that's what I'm giving you now. Oh, we forgot one more. We have
The cyclo thingy?
Yep.
Is this still branching hydrocarbons?
These are
this is the pen stuff.
But they're special ones, right? So in this case, since this guy is all connected, we call this cyclo. So how many carbons do we have in that center?
5.
1, 2, 3, 4, 5.
Okay. So we call a 5-carbon what?
2.
A 5-carbon
Cyclopentane.
cyclopentane. Okay. Now it has how many functional groups hanging off of it, and what are those functional groups?
It has dimethyl
Okay.
off of it.
Okay, so then we'd go 1, 2, dimethyl. Cyclopentane. Okay. So if it's a ring structure, that means it gets cyclo in front of it. And then the number of carbons that are in that ring structure. And then if there's something coming off the ring structure, you say where it's located. And you number it, it's pretty much random, right? You start it on the functional group that has the most importance. In this case, they're both the same. So I can start it here, say that's 1, 2. 1, 2, 3, 4, and 5.
I guess I'm getting a little caught up on this. A and E is all single bonds. YL is single, EN is double, and YN is triple.
Okay. So let me help you out a little bit. Okay? So we have what we call the prefix, right? YL. So that's when you're talking about the side chain. So if it's only single bonds, you put a YL. How many carbons it is? YL. Meaning prefix before the N. And then it's A and E at the end. That's your suffix. Okay. We have, in terms of priority, alkanes has the next priority. So that one is YN. And then if it was a side chain with the triple bond, you'd put YN, YL. Okay. But I promise you I won't do that to you this exam. And then YNE is our suffix. Okay. If we have alkenes, that's EN, or it's, if it's a side chain with a double bond, it is EN YL. Okay.
Okay.
Okay. Questions, concerns, Cash? Okay, you guys ready for the next one?
Yeah.
Okay, so let me copy some things over. Come on, there we go. Okay, so our next guy is the halides. So that guy is just going to have an O. Okay, so alkaline halides are carbon structures that have halogens. Okay. So we would name these guys the same way that we name the other structures. Only thing we'd say count our carbons, longest carbon chain, 1, 2, 3, 4. We want the functional group to be on the lowest number. So if I count it this way, 1, 2, 3, 4, 2 would be lower than if I count it this way, 1, 2, 3. So this guy would be 2 chloro. What is a 4 chain carbon called?
But
Hey.
Butane.
oh, butane.
That's all right. Everybody says it in the beginning.
Oh, is
That
that why?
would be 2-chlorobutane. Okay. Let's see, somebody has something in there. Okay. Let's see. Okay. So it goes in terms of priority, who has priority first, and then you want to go in terms of the numbering. So you want to try to get the guy who has the highest pecking order, has the most priority, the lowest number first, and then everybody else gets second dibs. Okay, so in this case, what would be the name?
Pentene.
1-pentene.
Okay, so it'll be, you said 1-pentene. Okay.
And it would be 4-fluoro, right?
Okay. 4-fluoro.
3-methyl.
3-methyl. And you want to put it in alphabetical order. So here on out, you're going to be using alphabetical order.
Yeah, so my question is, let's say you have a methyl section and as well as an ethyl section. Because of the alkyl halide, you even start putting those in alphabetical as well?
Yeah, you're going to just, it makes everything.
Okay, that makes sense now.
Yeah, unfortunately. But I guess it's a little easier because then all you have to do is remember alphabetical order rather than remembering, okay, who has priority and then who has, so. Okay. Questions, concerns? And I'll be a little lenient on that part, long as you make sure you have all those structures available. A little lenient, not too lenient.
2.
Okay. Are you with me? Did she leave,
Let me
Heather?
see. 3-methyl. 3-methyl.
You don't see 3-methyl?
One, there's a things hanging off, right? 1,
Yep.
2, no. 1, 2, 3.
Okay, so that's the third carbon. You have a methyl group hanging off the third carbon.
Okay, and then 4-fluoral is the fourth one with that F.
Mm-hmm.
Why are we putting the 3-methyl again? Because methyl, our plural, we're doing alphabetical, but how come it
Okay.
wouldn't have been like 2?
Because it's
4.
on the third carbon. It's coming off of the third carbon. This is your first carbon. This is your second carbon. That's your third carbon. And you have a
And
methyl
single
group
chain.
off the third carbon.
I mean, how come it wouldn't be 3, 4 dash something methyl?
because there's only one methyl group,
Okay.
right? This is a methyl group. This here is a fluoro group.
Floral. All
Yeah.
right.
Because that means that's bonded to the F.
Oh, okay.
Yeah,
So
coming up.
if that element was different, it would be like for something else.
Yeah, it would be bromo if it's Br, right?
All right.
Okay. But that's only for the halides, okay? Because when we get to nitrogen, it's going to be different. Don't worry, we're getting there next. Okay, one more for the for posterity.
Dr. Andrew, I was going to tell you, can we do one more of those since I'm starting to get the hang of it now?
Okay.
Just one more.
Actually, I can stay for this last one, but I have to take off.
Okay.
All right. See you later, Dr. Henry.
I'll see ya. Have a good night or a good day.
You too.
Halides is the halogens.
That's right.
So it's only that group. Okay. FClBrInt.
Okay.
Okay. First thing I want to do.
Not the longest chain.
Okay. Where should I start counting?
Counting from the triple bond because of the priority.
Okay. That's 1, 2, 3, 4, 5, 6, 7.
Heptine with the
Okay.
1.
So 1 heptine. Okay. Oops. Okay. And then what goes in front?
3 bromo.
Brolo. And then
Bromo.
it would be 4 butyl, not butyl, butene.
Butyl.
Or no, that's 2, isn't it?
Yeah,
Yeah,
the
that's
ene is
2.
for the bonds.
So then it would be
4 butyl. Or no. Ethyl.
4
Ethyl.
ethyl. Okay.
5 fluoro.
5 fluoro.
Why did you guys choose to go bromo, ethyl, and then floral in that way first?
Alphabetical.
Okay, thank you. Floral.
So that's it right there, Dr. Henry?
That's it.
All right, so it says we start counting from the triple bond because that takes priority, and then we go alphabetical route after that.
That's right.
Cool.
Okay. Okay, you guys ready for the next one?
Yes.
Ready to move next? Okay. Yeah, another. Oops. Oh crap. Oops. Okay. Let's see. We have oops. Amines. So the prefix would be amino. The suffix would be amine. Okay. So amines are basically you have N, and then you have, I'm going to use the term R. R stands for any functional group. So any hydrocarbon or hydrocarbon functional group. Let me know. You could also just have R, and these could be hydrogens. Okay, so I'm going to give you an example. Okay, so in this case, this guy would be named 1, 2, 3, 4. So 4-carbon chain, it's called.
Is there supposed to be an R hanging off of that N?
No, R is just a generic term.
Oh, I
So R could be anything. Yeah.
Butane for the 4.
Okay. So we call it butyl. And then we have a single carbon.
Methyl.
Amine. Okay, so the guy would be called butylmethylamine.
Butylmethylamine.
These
Simple.
ones are weird.
What was that?
I said these ones are weird because I don't know. Looking at them, it makes you feel like you need to write or do more.
Yeah,
it's missing
and it's
something.
not. It's just
Dr. Henry, why methylamine?
why methylamine? Because you
Yeah.
only have one carbon off here.
Oh, okay, so they're the. Oh, okay, I get it now.
Where this one you have, that's 1, that's 2, that's 3, that's 4.
Right, I get that one.
Okay. So
It's because he left it together. That's what threw you off, huh?
oops. Okay. What about this guy?
I'm going to say this, Dr. Henry, as a joke, but that looks like if a kid, like a little kid, would just draw those squiggly lines. Looks like it.
Yeah,
Is this
that's
what butyl?
that's how organic chemist starts with most of the drugs that are made. You know, they're just, okay, I'm just gonna draw something out and let's test it out, and we'll put it in a rad, see what happens to that rad.
Ooh.
So for this one, would this be butyl chloro hexylamine?
Okay, so you said that's 1, 2, 3 here. There's 3 carbons here. So you said,
Oh, 1, 2. Yeah. So sorry. So no. So not the propyl first then. So then.
you said chloro.
Mm-hmm.
Okay.
And there's a hexyl in there.
And then there's a hexyl. So that's 1, 2, 3, 4, 5. You mean?
Is it? Wait. Is it?
It's
I'm
still-
counting. I'm starting the first point from the one that's closest to the N.
No,
That's where
that's
I'm
just the
scoring the
bond.
pair.
That's the bond between the N and that first carbon. So that
Okay,
would be
so
1, 2, 3, 4, 5.
okay, so it's pentyl and the propyl.
Okay, so it's pentyl
propylamine.
Okay. Chloro, pentyl,
Propylamine.
propyl. Okay. Good job.
So every time it ends, that's when we have that's when the suffix of amine goes in, right?
That's right.
All right.
Okay,
Okay.
so I'm just curious. So this one we started with the element, we did chloro, but then on the last one, the butyl, how come
Mhm.
we did anything with hydrogen? Oh, because hydrogen is sometimes in there?
There's no hydrogen in there. So you don't have to worry about hydrogen. Hydrogen is kind of, remember, hydrogen is just that it's the thing that you put there just to kind of put there. You know, it's like, okay, it's there, you know,
Like a filler?
kind of make sure you have it. Yeah. So you don't worry about it in the nomenclature.
All right, so if there's any other like elements in there, then we would always put them first, like the chloro.
You put it in alphabetical order.
Oh, okay. So regardless, it's all alphabetical order then.
Yeah.
Okay.
Okay. And remember, nitrogen can only have 3 bonds, so you can only have 3 different types, 3 different attachments at most, right? So 3 different names there. Okay.
Oh, I see. Okay.
Okay. Let's see. Let me copy
Can we
this.
do one more?
Yeah, we can. Let's see. This is an evil one.
Oh.
So for this one, would this just be because you said it can only have 3, right?
Yeah, it could only have 3, but remember, it can have 3 attachments. So that attachment could have something on it as well, too. Right? So let's look at,
Oh, okay.
that's my hint. So that's 1, that's 2, that's 3, that's 4.
So
Okay.
then can you call it like how we had the other things where you said the
That's right.
location with okay,
Okay.
so would
So
this
that,
be well for the chloro, so would it be yeah, 1 chloro or 1
chloro, that's right, 1 chloro dash, because it makes reference to what it's dashed to. So then you'd say butyl.
all together, and that's
Yep.
considered one name?
That's right.
Oh, okay, I see it now too.
Okay.
I feel
Okay,
like I
and then
tapped out.
you can continue with everything else.
Yep. And then you'd have ethyl.
Ethyl, and then you would have hexyl.
Okay, is that 1, 2, 3, 4, 5, 6? So hexyl.
Amine.
Yep. Okay. That's it. Oops. Sorry. There we go.
Wait, is it hexylamine or hetylamine?
Hexyl, because that's 1, 2, 3, 4, 5, 6 carbons. So remember, this here is just the bond between the nitrogen and that first carbon. So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6.
Oh, so that was on me, and I miscounted it then.
Okay. Okay, we have one more that I'm going to go over, and then we're going to have to stop till Monday. Okay, so let me copy this. Okay, our next one are alcohols. I know you guys love that one, right?
Yeah, I do.
You're yawning? Is this boring? Is that what you're saying?
No, it's my nap time. 2 o'clock, 2, 3 o'clock. Looks like go down at this time.
And then and OL is the suffix. We'll start simple and then we'll work our way up. Okay. This guy is called
This looks simple.
Ethanol.
Okay. So it's called ethanol because they're all single bonds and it's attached to that OH group. So alcohols have OH attached to it.
It would be 2, wait, the number, 2 butanol or?
2-butanol. Yeah.
Okay.
Okay. So since the alcohol is on the second carbon, we have 1, 2, 3, 4 carbons. So that's butyl. And then it's all single bonded. So it's butanol. Okay. Let's add some complexity.
So it's six chain. So it's going to be
Hexanol.
Okay. Is it going to be hexanol or
hexanyl.
Yeah, hexanol. I'm just saying it funny, but it's the ENYL one.
Okay.
And it's going to be 3.
Okay. 1, 2, 3. Okay.
And then it's going to be 2-methyl in front.
Oops. I should not use the same color. So 2-methyl in front.
Followed by 4 hexene. No, never mind. Or just hex.
So 3. So it'd be 3 hex 4 enol, right? Or oops, sorry. Yeah. Okay.
Wait, what? That second one would be another way to write it?
Yeah.
Second one makes more sense to me. Because like on the first one, the 3 hex makes me think that the double bond's on the 3.
But usually if it's here, this pertains to the last name. So that OL.
Yeah, it's so weird.
Dr. Henry, how did you get the 3 hex?
Double bond here.
Yeah.
Okay. So then that's where I get it from. So if I count it, 1, 2, 3, 4, 5, 6. I get it. The hex, 6 carbons. The 3,
Right.
the 3 stands for the OH, where the OH is at. That's the OL. It tells me where the OL is at. Okay. Or you could write it this way, where then you put the number before the structure.
Okay.
Oh, I see what Edgar was saying now. Yeah,
Yep.
because I was like, wait, why are we bouncing from that 3 to the back of the name? Okay.
Because the second one, it's hex, which is 6. And on 4, there's the EN. So
Right.
a bond. And on 3, there's the OL. And we
And
know
just remembering to put all those dashes with those little tinies. I think that's
It's all a hot mess to me, so don't worry about it.
Okay. So let's see. Then we have, I'll give you easy ones here. 2. So this guy could also be called ISO 1, 2, 3, 4, 5 pentanol. Or we can call it 3 pentanol. Okay.
What's ISO stand for?
Same.
the half point.
So it's like the same on both sides. Yeah. 1, 2 on this side, 1, 2 on that side.
Okay.
Okay. So the weird thing is that when you have this guy, even though that alcohols have priority, oops. This guy would be called methyl. No. Methyl. Methylamine. Oops. Why didn't we do that? Ethyl methanol methylamine. Even though methanol technically has priority.
So if there's an amine, you always end with an amine?
It's so technically with IUPAC, it should be, this is the way it should be written, but nobody obeys that rule. So organic chemists never obey that rule. They do it this way instead. The way it should be written, it should be, what is this? That would be, so. It'd be ethyl methyl methyl one. Amino. Methanol. So this is the way it should be written, but nobody writes it that way. So it should be ethyl, methyl, amino, methanol.
Okay.
Yeah. So, but it's written this way. Yeah. So usually they give most people, because it's easier to see when you write it, ethyl methanol amine compared to ethyl methylamine methanol. Okay. You want to try one more?
Sure.
Sure.
Sure. We'll give you a hard one then.
So it's a carbon chain of 7, and we start with alcohol because of the priority.
Okay.
So it'd be 2,3 heptanol, at least for now.
Or would it be di? Is there such thing as a diheptanol?
Right.
Oh yeah, diheptanol, you're right.
Would it be diheptanol or would it be diol? Heptadiol.
Heptadiol?
Yep.
Yeah, it would be heptadiol.
Okay, so we have heptadiol.
With a 4-chloro.
And you said 4,4?
4-chloro.
4-chloro.
And
Because there's a triple
is
bond.
it 6? Yeah, would it be a 6-heptine? Not 6. Hextine.
So it's a hept dash 4 or dash 6 dash YN dash 2, 3, 2,3 dash diol.
That is correct.
Is that the other way to write it?
That is the other way to write it.
Okay.
Or you've written it as No, actually, that would be the only way. Main chain. There's nothing else there. Yep, that would be the only two ways.
Are you gonna dock us if we mess up on the hyphenations?
You want to make sure they're included. So it depends, because the hyphenation makes a really big difference under certain circumstances.
Yeah. It's just because the bottom one looks like it's all connected, but then the top one, we have it separated with a comma. Which one's the easier one on that? The last example? The first or second to write it?
I don't know. It just depends on your style, whatever, because both of them are correct.
Okay.
So you always use the I always remember that put the A. You always use the hyphen in front of, like, if you have numbers in front, and then your numbers in front and hyphen or dash. Yeah.
And then a number in the back though too?
Yeah, here, if it's in between, a number in front and back, right?
Okay.
So that's part of the entire thing.
Okay.
Okay.
So hep diol cannot be put together.
No, it can't be. You have to put the I in. I mean the YN in it, because it's all part of the main. If you had another, let's say you had a double bond in here as well, then you could put the YN out, but you'd have to put the EN in. Does that make sense?
Yeah, so because then the en would have taken precedence over that yn. So think of hept and the diol, like everything in the middle needs to reflect the main base.
Yeah, that's right. Yeah.
Okay.
That's a good way of thinking about it. I have to use that. Okay. So how are you guys feeling?
It's fine. It's just the fact that the naming rules change from like example to example is so weird.
Yeah. Well, they're pretty much consistently the same, but you know, you just have, and you got to remember, like in terms of complexity, right? So things got more complex later on, so we had to adjust those rules. So you guys are due for another rule change, which is, like you're talking about specifically with the amines, right? So you go back to the old way, but rather than the new way.
I think with practice, it'll get easier.
Yeah, and then the worst part is that we haven't even got to ethers yet. And everybody, there's a certain way that you're supposed to write ethers, and nobody writes them that way. Nobody, not even people that made up the rules initially, how they write them. You know, look at every publication.
But we're gonna learn to work.
Yeah, you'll learn. You'll learn a few more, and then. But I'm just going to give you a subset. I wanted to focus on alcohols because you're going to see alcohols again. You're going to see carboxylic acids. You're going to see. So those are some of the ones that I want to make sure that you guys got. But there's. I'll show you the list. And then, like I said, I'll post it onto. I remind myself to do that. There are quite a few. Yeah, here you go. You guys see it?
Yeah.
Yes. These are all of the function groups. Right? And you guys should have that on the back of your packet. Harnell, you guys don't, so let me put that up now. Do your resources. Otherwise I'll forget. And so I will provide you guys, let's see. So on your exam, you guys are able to sit there and use the sheet for your exam. Let's see. And else.
How does that work? Like, honestly, I know you said it before that we can use our resources while we're taking the test.
Yeah.
But I always feel like if I click into anything while Proctoria is on, it's gonna like shut down my test. I just
No,
don't
no, no. So what
click
I'm
on the
saying,
side.
because you actually had a packet with all of these, right?
Yeah, I do.
Yeah.
I do have the packet.
Yeah, and so that's what I'm saying. The resources, all your resources in that packet are available. So that's basically all of that resource sheets in Canvas are all in that packet.
Oh, I thought you were saying to like open it on the test on the
Oh, no.
screen.
No.
Oh, okay, never mind.
Yeah, so let me see right now.
This is all the new material that you're covering?
Yep, that's all the material that I covered in lab. Yep.
Okay.
So we'll be adding, no, it's not all of them because there's more. There's more.
To come, yeah. But I mean,
Yeah,
like
we have
for
a few
now,
more. We have a few more functional groups and then we'll be good. So because we've done alcohols, we'll do ethers, we'll do esters, and we'll do aldehydes, ketones, and carboxylic acid.
are we gonna do those next week or this week coming up?
Yep.
Okay. And all of this is gonna be on the exam?
Yeah. Yep.
Are we gonna have a practice test for this exam?
Yes, you will. Your practice test is going to open up on Monday. It'll be open until you guys finish the exam. The exam is going to open up on Friday, so you'll have Friday, Saturday, Sunday, Monday to get it done. And then, yep, and that's it.
Okay.
Let's see.